So we'll talk about abnormal JVPs here. So we know that the A wave was due to the atrial systole. Atrial systole will increase the pressure in the internal jugular vein. C wave was due to the bulging of mitral and tricuspid valve into the atrium. And X descent was due to the atrial relaxation. The atria will relax, so giving us X descent. And V wave was due to the volume overload in the right atrium, because the atria is being filled, there is volume, and due to which there is a V wave. After V wave, we will have a Y descent, and Y descent was due to emptying of the atria into the ventricles. So it was due to emptying, leading to fall in pressure in the internal jugular vein, giving us a Y wave. So let's look at the abnormalities. So A wave can be absent or large, or can be very giant. So why the A wave will be absent? Either because A wave is due to the atrial contraction. So if in conditions such as atrial fibrillation, the atria doesn't contract, that is, that there is twitching in the atria which lead to insignificant contractions. So in that condition, the A wave is absent. So atrial fibrillation. And we also know that the P wave of ECG denotes the atrial depolarization. So atria doesn't contract, so in atrial fibrillation even the P wave of ECG is also absent. And we know that the S4 heart sound is when the atria generates more pressure in order to pump blood from atria to ventricles. So atria contract vigorously in order to produce S4. So but in atrial fibrillation, the atrial contraction are insignificant, so even the S4 will be absent. So remember that in atrial fibrillation there are three things absent: the A wave of JVP, the P wave of ECG, and the S4 heart sound. Coming on to the large A wave will be seen when the atria has to contract with much higher pressure in order to throw blood from atria to ventricles. So what are the cases in which the atria has to apply more pressure than usual? These can be the outflow tract obstruction, like in case of tricuspid stenosis or pulmonary stenosis. And even the long-standing mitral stenosis can cause large AV, because we know that in mitral stenosis what will happen: suppose this is mitral valve and it is stenosed, it will increase the pressure of the left atrium, and left atrium increased in pressure will cause pulmonary edema. So there will be pressure in the pulmonary artery, and which will result in hypertrophy of right atrium. So right ventricle hypertrophy. So right atrium has to pump very vigorously and generate more pressure in order to push blood into the hypertrophied right ventricle. So this will lead to large A wave in long standing MS also. Other causes which we discussed were tricuspid stenosis, pulmonary stenosis, and also we can write pulmonary artery hypertension because there is outflow or resistance, and tetralogy of Fallot because there is subpulmonic stenosis in it. And we can also write Epstein anomaly because we know that the tricuspid valves are displaced and abnormal in it. So these are the condition of the large A wave. Talking about the Canon A wave, giant A wave, we see this in condition where where the atria and ventricle contract simultaneously, generating a huge amount of pressure, resulting in a large A wave. I mean giant A wave, very large. So what can be those conditions? Those conditions can be either junctional tachycardia, because what happens is that AV node generates impulses and it gives impulses to atria as well as ventricle, and a point can come where they will contract simultaneously, that is atria and ventricle contract simultaneously, generating a large giant A wave. And so one condition is the junctional tachycardia. Other condition can be third degree heart block. Third degree heart block in this condition also what happens is that there is asynchronicity between atria and ventricle, that is atria is contracting at its own pace and ventricles are contracting on its own pace. So there can come a time when these two contract at the same time, at the same moment, so generating a canone A wave or joint A wave. So what's the difference, how will you differentiate between large and canone A wave, is that you will see large A wave in every heartbeat, but that will not be so in case of canone A wave. So here you can see there's a canone A wave in this diagram and there is large A wave in tricuspid stenosis. Moving on further to the X descent. So why was there X descent at the first place? Because the atrias were relaxing. Due to atrial relaxing, these walls also going down because of ventricular emptying. So now let's talk about the abnormalities. So absent X descent will be seen in case of tricuspid regurgitation, because we know that in tricuspid regurgitation there will be backflow of the blood. When the ventricles will contract, the blood will flow backward because the walls are faulty, and so the atria which was now relaxing will have more volume and it will not be able to relax, and instead there will be volume overload from the ventricles. So tricuspid regurgitation will have absent X descent. And talking about prominent or steep X descent, we can have that in cardiac tamponade and constrictive pericarditis. So we will discuss these two conditions at the end of this video. So just remember these two under this heading for now. Talking about V wave is absent. V wave was due to the, here is the V wave, it is due to the volume overload in the atrium, because the volume because there is much volume in the atrium and it is increasing the internal jugular vein pressure. So when will it be absent? It can be absent in conditions where the adequate amount of blood is not reaching into the atrium itself. So there will be less volume here, so V wave will be absent. Such conditions can be hypovolemia. So talking about prominent V wave, we can write here hypervolemia. And also the important one is the tricuspid regurgitation, because as discussed earlier, in tricuspid regurgitation during the ventricle systole there will be backflow of blood which will add on to the volume, and because of the volume we were getting V wave, and now because we have extra volume here we will get prominent V wave. So now moving on to the Y descent. So Y descent was due to when atria was emptying itself into the ventricles, we were getting Y descent. So it will be absent in cases of tricuspid stenosis, because it is obvious that in tricuspid stenosis these walls will be stiff and stenosed, so atria will not be able to empty properly into the ventricles. Other cause is cardiac tamponade, and the steep prominent Y descent is seen in tricuspid regurgitation, because we know that in tricuspid regurgitation the blood has accumulated in atrium during the ventricle systole. So now there is so much volume of the blood that when these valves will open, the huge amount of blood will rush into the ventricles, therefore causing a steep Y wave. And other causes cardiac constrictive pericarditis. So let's see why there is steep or absent Y descent in these conditions. So what happens is, in cardiac tamponade, suppose what happens is there is a fluid accumulation around the heart. So due to which what happens is our ventricles get compressed. So now the ventricles have shrunken, and what will happen is that when the atria will empty itself into the ventricles, the atria will empty itself into the ventricles. So the atria will not be able to pump its blood into the ventricles because the ventricles are already shrunken. So ineffective emptying of blood of atria to the ventricles, causing an absent by descent. While coming to the constrictive pericarditis, what happens is, suppose this is the heart, and here there is diastolic resistance because the ventricles cannot relax fully because of the constriction. So what will happen is, the whatever blood has to come from atria to ventricle will come in the phase of early diastole. What are the maximum amount of blood has to come will come in the early diastole, because the heart knows that in the mid and late diastolic phases the constriction will not allow the ventricles to relax. So all the blood will come in the early diastolic phase. So there will be a steep Y descent, because in mid or late diastolic phase, due to the constriction, the ventricles will not be able to relax. So all of the blood comes in early diastole and there is such a rapid filling of the ventricles. So in constrictive pericarditis, we will see an steep Y descent. So here we have seen this case, and talking about the X descent, there will be steep X descent in both constrictive and cardiac tamponade and constrictive pericarditis. Why? Because we know that X descent is due to the atrial relaxation. So it has been hypothesized that because the ventricles are constricted due to the fluid or due to calcification or other causes. So what will happen is that when the ventricles will go into systole, they will contract vigorously. They will try to contract very very vigorously with much pressure, because in order to put the blood into atrial pulmonic artery, because they know that already they are being constricted, so they have to apply more pressure in order to eject blood into the atrial pulmonic valves. So what will happen is that these tricuspid or mitral valves will go down, and there will be more space for the atrial relaxation. So there will be steep X in both these cases. So coming on to the Kussmaul sign, so normally what happens is that JVP should fall with inspiration. But in Kussmaul sign, what happens is that JVP rises. Because why should it fall in inspiration? Because during inspiration, the intrathoracic pressure creates a sucking effect on venous return. So normally JVP falls, but in cardiac tamponade or constrictive pericarditis mainly, what happens is that there is an inability of right side of the heart to handle increased venous return. So therefore we will see Kussmaul sign mainly in conditions we can remember as CRR, that is constrictive pericarditis, and restrictive cardiomyopathy, and right heart failure. Which can be due to inferior wall MI or pulmonary embolism or COPD. So there are conditions in which we have non-pulsatile elevated JVP. So there are only two conditions in the medical field in which we will find the non-pulsatile elevated JVP, that is the cardiac tamponade and superior vena cava thrombosis. So remember these two conditions here. And now summarizing it all, so we have seen a condition in which there was absent X descent and a V wave and steep Y descent. Yes, I'm talking about tricuspid regurgitation, and we will see steep X descent and steep Y descent in case of, we have seen here, constrictive pericarditis. You can see we have steep X and steep Y. While we have steep X and absent Y in case of cardiac tamponade. So that's it. Thank you.